Welcome to today's explainer. Let's just jump right in, shall we? Every single time you ask Snapchat's AI to write a text for you, or you use ChatGPT to brainstorm a school project, or you're just scrolling through a flawlessly curated TikTok feed, you are actually triggering a massive, totally invisible war. And it's not a war of code, it's a physical war of silicon. Today, we're cracking open the servers of the biggest tech giants to understand the secret hardware race that literally powers your daily life. We're talking about the great chip race and how artificial intelligence fundamentally broke and then had to completely rebuild computer hardware.
Now, to really understand the hardware side of things, we first need to bust a pretty massive myth. How does an AI actually think? Well, pop culture loves to tell us that neural networks are these magical, glowing digital brains, right? But the reality is way less mystical. AI doesn't actually think at all. At its core, an AI is really just a massive, overwhelming, mind-boggling pile of simple math.
It turns out, the whole magic trick is actually an incredibly simple operation called matrix multiplication. You just take a grid of numbers representing your inputs, you multiply it by a grid of numbers representing weights, you add a little bias number, and boom, you get an output. That's the whole secret. It's just multiplying and adding. It is incredibly trivial math that honestly any middle schooler could do, but the catch, and this is a massive catch, is the scale. A single query to an AI like Gemini or ChatGPT doesn't require doing this math once. It requires trillions of these operations all at the exact same time. And that sudden need for trillions of simple math problems, it entirely broke the computer chips we were using.
Which brings us to contender number one in this hardware war, the CPU, or Central Processing Unit. This is the exact chip running inside your laptop right now. For the last 50 years, the CPU has been the undisputed king of computing. It is the ultimate genius generalist. It's built to handle basically any task you could ever throw at it.
But here is the ultimate trade-off. A CPU core is wildly sophisticated. It can run a web browser, play a high-def video, and compile code all at the same time. It can even predict which way a line of code is going to go before it even happens. But because they are so incredibly smart, these processing cores are physically huge and very, very expensive. Because of that, most consumer CPUs max out at around 16 cores. So think of a CPU like a team of 16 brilliant math professors. They can solve literally any complex problem in the universe. But if you hand those 16 genius professors a stack of 1 trillion basic addition worksheets, which is exactly what AI is, it's going to take them years to finish.
Enter contender number two. And honestly, this is where things start getting pretty wild. For decades, tech companies didn't build GPUs, graphics processing units, for AI. They built them for something you are probably very familiar with, video games. It's actually kind of crazy to think that gaming built the foundation for artificial intelligence, but it absolutely did. Just think about the number 8 million for a second. When you are playing a modern video game in beautiful 4K resolution, your screen has over 8 million individual pixels. And the color of every single one of those pixels needs to be calculated independently, at the exact same time, 60 times a second. You don't need a brilliant math professor to calculate the color of a single pixel. You just need a basic calculator.
So instead of building 16 smart professors like the CPU, GPU makers like NVIDIA basically built a massive stadium filled with 16,000 basic calculators. This is called parallel processing, or SIMD, single instruction, multiple data. Basically, thousands of quote-unquote dumb cores all receive the exact same instruction at the exact same time, just applied to different data points. It's a completely different way to manage information, designed entirely for crunching millions of tiny tasks at once. Then, right around 2012, researchers stumbled onto this massive plot twist. The math required to calculate 8 million pixels for a video game, it is structurally identical to the matrix multiplication required for an AI neural network. No way, right? But it's true. It's all just giant grids of numbers being multiplied and added in parallel. The GPU was totally the accidental hero of the AI revolution. It literally catapulted NVIDIA into becoming the most valuable chip company on Earth. But accidental is the key word here. The GPU is still a generalist. It does graphics, it does physics, and it does AI. It's great at all of them, but it wasn't born purely for AI.
So, enter contender number 3. Around 2015, Google decided, you know what? We don't want a chip that can play video games. They wanted a chip that did exactly one thing, matrix multiplication with absolutely zero wasted energy. So they built the TPU, the Tensor Processing Unit. Under the hood, a TPU uses something called a systolic array. It sounds super complex, but it's literally just a physical 2D grid of tiny hardware units. Think of it like a highly efficient assembly line passing buckets of water. Step 1, the data flows in from the top. Step 2, the unit multiplies and adds. Step 3, it instantly passes the result straight down to its neighbor. Unlike a GPU, which has to constantly stop what it's doing to fetch new instructions from memory, a TPU acts like a continuous wave of data. The numbers just keep physically flowing through the chip on that assembly line, doing math the entire time. It is the absolute ultimate expression of specialized hardware.
And hey, you might not have ever heard of a TPU before today, but you are absolutely using them every single day. Every time you run a Google search, or get trapped in a massive YouTube recommendation rabbit hole, or translate your Spanish homework, or ask Gemini a question, you are quietly using a TPU. Google has actually been running these in the background for years to power all their main apps.
Which brings us to a huge announcement from Google just this week, and really the core mystery of this whole hardware race. Why did Google just announce two different 8th generation TPUs? It's the same generation, built by the same silicon team, but they released two entirely different chips. Why in the world would they split them up like that?
Okay, let's unpack this, because it reveals a huge secret about how AI actually works under the hood. The tech industry recently realized that running an AI is actually two completely different hardware problems. First, there's training. This is teaching the AI by feeding it basically the entire internet. Training is what we call compute-bound. It requires massive batches of math and raw computational throughput. But then there is inference. This is when the AI actually answers your prompt in real time. Inference generates just one word or token at a time. It doesn't need raw math power, it needs instant, lightning-fast memory access so it doesn't lag out while generating your answer. So inference is memory-bound.
Google's solution? Just explicitly split their chips to perfectly manage data for these two very specific jobs. They have the TPU-80, which is the training chip. They link 9,600 of these bad boys together to create a massive brain of pure, raw compute power. But for the TB8, the inference chip, they took a totally different approach. They actually tripled the ultra-fast on-chip memory, the SRAM, and put it right next to the processing cores. By putting the memory physically closer to the math, they drastically cut down the latency, so the AI can literally talk to you faster.
This whole split, it actually reveals a massive philosophical war playing out in real time across the tech industry. As the saying goes, you either specialize or you lose on efficiency. NVIDIA's strategy is to build one incredibly powerful general AI chip, the GPU, that can handle both training and inference, and just let the software figure out the details. Google is betting heavily against that. They are saying, nope, the physics of data management have diverged way too much, and you absolutely must have specialized hardware for each specific task.
And that leaves us with this final, massive question to ponder. Will the ultimate specialist defeat the ultimate generalist in the AI hardware wars? As these giant tech companies race to build the smartest artificial intelligence, the true battle isn't actually happening in the code. It's happening right there in the silicon. The winner is going to define the future of technology for decades to come. Thanks for joining me for this explainer. Keep wondering, and I'll see you next time.